to look at some special right triangles. This will save you all kinds of time and allow you to do problems that you couldn't do directly with the Pythagorean theorem. So here it says find the length of the hypotenuse in each isosceles right triangle. Hopefully, by this point, you were done with those and you got that this was 5 square roots of 2, and that this was 7 square roots of 2, and that this was 10 square roots of 2.
Whoa.
I noticed that on the homework last night.
Oh, there was what? Yeah, there was one with 5 and 5, and it was 5 square roots of 2. Yeah, exactly right. So if we know it's an isosceles right triangle, and we know the lengths of the legs, all we have to do is multiply. People sometimes say add on the square root of 2. We're not adding, we're multiplying the length of the leg times the square root of 2, and we get the hypotenuse.
Right.
So if we know that both of these are 6, if both of these are 6, the hypotenuse should be
6 square roots 2.
6 square roots of 2. Page 2.
Is this our whole lesson?
No.
Dang.
So in an isosceles right triangle, and I'll point out in an isosceles right triangle, the angles are 45, 45, and 90. Right? We have a right triangle, and it's isosceles. And because it's isosceles, the two base angles have to be the same.
Oh, right.
So it'd be a 45, 45, 90 triangle. Then the hypotenuse is equal to the leg times the square root of 2. So that means the leg is the hypotenuse divided by the square root of 2. So that allows us to do all kinds of problems. So here, we have the hypotenuse. We're trying to get the leg. It's a 45, 45, 90 triangle. So x is just going to be 12 square roots of 2 divided by the square root of 2, which is 12. I wouldn't even expect that you would write anything down for a problem like that. All right, here we have the legs and we're looking for the hypotenuse. You can do the Pythagorean theorem on this problem if you really want to, but it takes time. It takes much less time to go, okay, the hypotenuse is going to be equal to the leg times the square root of 2.
Which is 8 times 4, which is 32.
Try again.
I mean 8 times 2, which is 16.
Wait. Oh. Yeah.
Okay. So x is just 16. And it doesn't have to have a square root of 2 involved with it at the beginning or at the end for that matter. Take a look at that.
Okay.
Thank you. Take a look at this one, for example. It's a 45, 45, 90 triangle. So I know this side's 11 square roots of 3, but they didn't ask, and we don't really need to write it down. And then the hypotenuse is going to be the length of the leg, 11 square roots of 3, multiplied by the square root of 2,
So 11 square roots of 6.
11 square roots of 6. On this problem, we're given the hypotenuse, and notice it didn't tell you that it's 45, 45, 90, but they tell you both of these sides are x, so it's an isosceles right triangle, which is the same thing as a 45, 45, 90 triangle. So then how can we find the lengths of the legs from the hypotenuse?
18 divided by square roots of 2.
Yeah, we're going to divide by the square root of 2. Remember that we can't leave a square root in the denominator, so we'll rationalize the denominator by multiplying by the square root of 2 over the square root of 2. It's 18 square roots of 2 over 2, which is 9 square roots of 2. Most of you, not everyone, but most people will get to the place where they look at that problem and go, okay, and they can just do it in their head and write down the answer and move on. And if you can, that's fine. Okay, on Pythagorean theorem problems, I expect to see the Pythagorean theorem. But on special right triangle problems, I expect to see the answers. If If you have, work that you want to show, great, and I will look at it. But if you don't, not a big deal. All right. So what we're going to do on number 5?
23 divided by square root of 2.
Yeah, 23 divided by the square root of 2. So we're going to rationalize the denominator by multiplying by the square root of 2 over the square root of 2. And that gives me 23 square roots of 2 over 2. And since 2 won't go evenly into 23, and I'd rather not have a mixed number times the square root, just leave it like that. Okay, that is a perfectly good answer. All right. That's 45, 45, 90 triangles. Pretty straightforward stuff. Let's dive into 30, 60, 90 triangles. I knew that would work.
She's squealing again.
All right, so here we have an equilateral triangle, and we've done what's called dropping in an altitude. This segment right here that's perpendicular to the base is called an altitude. The length of the altitude is called the height, right?
Yeah.
And height and altitude go together. If you find the altitude of the plane, it's the height of the plane off the ground.
That's smart.
It's like what they used to do for parallelograms in 5th grade.
Yeah, well, we're going to continue to do them, but yes. Yeah, that's the altitude. So if we drop that into this, notice, what do we know about these two triangles?
They're
They are congruent. They both have a right angle in them. This side is congruent to itself. They both have a hypotenuse that it's 18. Yes?
Why don't they just call it like a bisector or a mid?
Because it's not a real
A bisector? Okay, so that's a really good question. And the answer partly has to do with, if you have a triangle which looks like this, are you going to say that this bisects the triangle or that this bisects the triangle? You can't bisect the triangle in this case. There's no way to split it exactly into two congruent triangles. It's true, though, that the altitude of an equilateral triangle bisects the triangle. It divides it into two congruent triangles. Okay? So if that's true and this whole thing is 18, how much is each of these pieces? 9. So there's 2 legs to this right triangle. The shorter of the 2 legs is going to be 9. How's that related to the 18? It's half of the 18. Now let's find out what y is by doing the Pythagorean theorem. That's going to be 9 squared plus y squared is 18 squared. So that'll be 81 plus y squared. 18 squared?
324, right?
Yep, 324. So subtracting, we get y squared is what, 241? 243, excuse me. It's like, whoop. So let's simplify that. 243, first thing that jumps to my mind is 3 goes into that evenly. That's 81 times. And I'm going to show you on this particular problem that if you want to abandon doing prime numbers, you can if you come up against a perfect square. 81 is a perfect square, right? Because it's 9 times 9. You don't have to keep going by 3s and 3s and 3s and 3s. You can go, okay, yeah, that's going to be 9 and 9. Because these two match. So y is 9 times the square root of 3. So if this one worked the same way, how much do you think x is going to be? 10, because both of these are going to be 10. And if we did the Pythagorean theorem, let's save ourselves some time, what do you think this would be?
10 squared roots of 3.
10 squared roots of 3. That is the pattern.
Wait, why? Yeah.
Because if I do 10 squared plus y squared is equal to 20 squared, I get 100 plus y squared is equal to 400. So y squared is 300, which,
Just do that in your head.
do what?
Pattern of the-
20 squared?
That's what we're
Whoa. Hang on. What are you asking? How did I do what in my head?
Like, how'd you just know that from looking at
No, which that?
10 square roots?
Oh, I'm using the same pattern that this one had. This was 18, this was 9, this was 9 squared roots of 3.
Oh.
This is 20, that's 10, it's half of it. And the pattern that we had over here is it was this number times the square root of 3. And it works out that it is, right? This is the square root of 100 times the square root of 3.
It's just gonna be that every time?
In this particular case, yes. So let's talk about this case for just a second. It has to be, you start with an equilateral triangle where all the sides are congruent. Now, if a triangle is equilateral, what else do we know about the triangle?
Its angles are equal.
Its angles are equal. And how big are all their angles?
60.
They're 60. So these little triangles, you know how we called the ones in the previous part of the lesson 45, 45, 90 triangles, because those were the angles? We're going to call these two small triangles 30, 60, 90 triangles, because those are the angles. So, page 3. In a 30, 60, 90 triangle, the short leg is the hypotenuse divided by 2, and this SL stands for short leg. Now, before we do anything else, how do I know that it's the short leg? And please don't say because it looks like it. Yes.
The 30 angle is the shortest.
Yes, the 30 angle is the smallest angle, so this has got to be the shortest side. It'll be the shorter of the two legs. And across from the 60 will be the long leg. The long leg is equal to the short leg times the square root of 3. That's what we got when we did that pattern. But turning that around then, the short leg times 2 should give you the hypotenuse. And the short leg will be equal to the long leg divided by the square root of 3 if we're going in that direction. All right, so let's solve these for x and y. So it's helpful to figure out what it is that you've got to start with. I don't require that you write it down or anything, but which side do we have out of this 30, 60, 90 triangle?
Short leg.
The short leg. And the long leg is the short leg times the square root of 3. So the long leg is the short leg times the square root of 3. So the long leg is just going to be 7 times the square root of 3. And the hypotenuse is the short leg times 2, so that's 14. It's just using that same pattern. The short leg's half the hypotenuse, and the long leg is the short leg times the square root of 3. It's the exact same pattern that we had here. I just turned the triangle sideways. Well, here, which side do we start with?
The hypotenuse.
The hypotenuse. The most important side in this is the short leg. You got to find the short leg before you can find anything else. So find the short leg first. How is the short leg related to the hypotenuse?
It's half.
It's half. So this is 12 over 2 is 6. Again, I don't expect that you're going to write the 12 over 2. You're just going to take half. And then the long leg is the short leg,
Times square root of 3.
so it's 6 square roots of 3. I think if you're given the short leg or you're given the hypotenuse, these are really easy. If you're given the long leg, they're a little bit harder. Because if you know the long leg, what are we going to have to do to it to get the short leg?
Divide by square root of 3.
Right, we're going to have to divide by the square root of 3. So this is 18 divided by the square root of 3. I'll rationalize the denominator by multiplying by the square root of 3 over the square root of 3. I get 18 square roots of 3 over 3, which is 6 square roots of 3. Again, many of you will get to the place where you can just look at that and go, oh, this is 18. So if I divide by the square root of 3, I'm going to end up with 6 square roots of 3. And if you can, great. I'm all for it. If you can't, I'm not judging you. I'm like, yeah, that's fine. So if the short leg is 6 square roots of 3, what do I do to the short leg to get the hypotenuse?
Times 2.
Multiply by 2. 6 square roots of 3 times 2 is 12 square roots of 3. The next two are just a little bit uglier because you get fractions involved, but they're not horrible by any stretch of the imagination. Which side do we have in this 30, 60, 90 triangle?
Hypotenuse.
Hypotenuse. What do we do to the hypotenuse to get the short leg?
Divide by 2.
Divide by 2. I'm always just going to leave that as a fraction. I try not to mix, do mixed numbers unless I have to.
I'm confused. How on number 3 did you do 18 divided by the square root of 3, but on this one you do?
Because this one I started off with a long leg,
Oh.
and this one I'm starting off with the hypotenuse.
Oh, I was looking at it wrong. Thank you.
Yeah, you're welcome. I appreciate you asking. So then, what do we do to the short leg to get the long leg?
15 times square root of 3.
Yeah, it's 15 over 2 times the square root of 3. And that's 15 square roots of 3 over 2.
What if you do decimals?
We try never to mix decimals with square roots if we can help it. Yeah, I know I'll have students write 7.5 square roots of 3, and it just, I don't know. And I don't know why we don't, honestly. I think that may just be by convention we don't. It's not wrong. It just makes me cringe. All right, so for this one, which side do we have?
The long side.
Be careful, not the long side. The long side's the hypotenuse. We've got the long leg. What do we do to it to get the short leg? Divide by the square root of 3. So we'll rationalize that.
That's a big one.
I have the hiccups.
So we have 11 square roots of 3 over 3. And then what do we do to that number to get the hypotenuse?
Times 2.
Multiply by 2. So it's 11 square roots of 3 over 3 times 2 is 22 square roots of 3 over 3. Fake bill number 2. All right, which side do we have in this 30, 60, 90 triangle?
Short leg.
Short leg. So since I've given the short leg, I can do whatever I want to first. It doesn't matter. To find the hypotenuse, what will I do to the short leg?
Times 2.
Times 2 is 8 square roots of 3. And to get the long leg,
Times square root of 3.
multiply by the square root of 3, so I'll have 4 square roots of 3 times the square root of 3 is 4 times 3, which is 12.
What would? between
1 and 2.
wait, but then the wrong leg is bigger. Oh no, because you're multiplying, so that could be 60.
Okay. All right, got a worksheet for you for homework. I think this whole unit is just Worksheet City.